Okay, so let me start it once again. So as we have seen, clustering, there are two types of clustering. One is the flat clustering, another one is hierarchical clustering. In flat clustering, okay, so you divide the data, or it is also called as a kind of partition based clustering. Okay, so in flat clustering, you actually have let's say data points, okay, somewhere here, 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 and then you partition that data and group that data in different clusters. Okay, so we have seen one example of that as k-means algorithm. Okay, now there is another there is another kind of type of technique in clustering, which is called as hierarchical clustering. Okay, hierarchical, the name itself suggests that there is a kind of hierarchy. So there are two types of hierarchy. One is the bottom up hierarchy, and another one is the top down hierarchy. Okay, so bottom up hierarchy, again in bottom up hierarchy, sorry, just a minute. In bottom up hierarchy, we have agglomerative kind of clustering, where you start with each and every data point, and then ultimately you actually add those points together, and then you sorry, just a minute, let me just give me a second. I just want to seal this. Okay, that is fine. So in bottom up agglomerative type of clustering, so you treat every data point as one cluster. Okay, and then you go on finding out some distance with this, and then go on grouping together, and then all these clusters are formed as a group. Okay, so that's why we say that hierarchical clustering gives you a kind of nested sequence. What do you mean by nested sequence of clustering? So you may have seen it in the programming language when you write if then else, and then if within if within f. So that is what is the nested if. Okay, so here you have nested sequence of this clusters. So let this be a cluster, this be another cluster. Then when you group this is called one group. Then this is what is another group. Then when you merge these two groups, then this whole will be a group. So it is a kind of dendrogram, or it is called as the nested sequence of the clusters. Okay. So let us see again revisit the types of clustering. So types of hierarchical clustering. How many types are there? Basically, there are two types. Number one is called as bottom up, which is called as agglomerative type of clustering. Okay, and second one is it's top down. Okay, as the name suggests, as you can see, this is divisive. Okay, what do you mean by divisive? In bottom up, we have seen that every particular data point is considered as a cluster, and then they are grouped. In top down, all data points. Okay, so I'll write it here. So all data point are considered as or you say grouped into one cluster. So all data point are considered as a into one cluster. And then ultimately, what do? You recursively, what do? Divide or split into different clusters. Okay. Different clusters, or you say, or a set of, you say, child cluster. Okay, so for example, let's say you have this data, okay, and you have all these data points, okay, it's here and somewhere here. So all are considered as one cluster. Then ultimately, then you will have this as next two child clusters. Okay, then again you will have one child cluster within this, one more child cluster within this, let's say one more child cluster here, and again go on dividing it. So top down is a kind of divisive, okay, and bottom up is agglomerative. So bottom up means what? You build the nested clusters on the data points. Okay, so we will be looking at the bottom up kind of bottom up type of clustering. Okay, so let me write this, let me clear this. So like yesterday, I will write algorithm. What is that? Agglomerative, and the input is D. And as you can observe the difference between the yesterday's algorithm, K-means algorithm, and this agglomerative algorithm. Yesterday we have given the input as K and D. So the K has to be initialized or supplied prior to the algorithm. Okay, but here we do not supply the number of clusters. Why? Because we will have all types of clusters. Okay, let us see one by one. Okay, so this is algorithm agglomerative. Let me write the steps. Okay, so first of all, make each data point in, let's say, D as a cluster. Okay, so every data point in D will be treated as a cluster. Then what do? Then you compute distance. I will write pairwise distance. Okay, compute pairwise distance between data points. Okay, and then this is the recursive step. So repeat, and here we'll find two clusters, let's say, that are near to each other. Okay, so you will find it with the Euclidean distance, that which are the two clusters near to each other. Okay, and then what you will do, you will merge the two clusters to form a new cluster. Okay, so you will find, let's say, if you find let's say A and B as two clusters which are near to each other, then you will merge A and B together to make it as A and B. Okay, so A, B will be a kind of, merge clusters. Okay, and then again what you will do is you will compute distance. Let's say merge the two clusters to form a new cluster. Let's say merge C. Okay, compute distance from C to all other clusters. Okay, and then what will be the break condition? Okay, repeat this until you will have, until there is only one cluster left. Okay, so you will find two clusters, go on merging it, another two clusters, or then you will merge those two clusters and go on merging it until there is only one cluster left. Okay, so this is what is the algorithm for bottom up hierarchical clustering. Okay, it is very easy and straightforward. There is a little, when you say compute pairwise distance. Okay, pairwise distance between data points, that is okay. But find the two clusters that are near to each other. So there is a problem in this. Okay, why it is so? Because when I say pairwise distance between two clusters, so let us say this is my one cluster. Okay, so I say these are 1, 2, 3, 4, 5, 6, 7 points. Okay, so this is my, let's say, cluster A. Okay, and let's say this is my cluster B. Okay, then there are different distance models that we generally use to find the cluster distances. Okay, so when I say, when you want to find out the distance between cluster, okay, or find out the cluster distances, then what probably you can have, the one thing that you can have is that I will choose this data point and this data point. Okay, and then find the distance between this. Okay, why this? Because this is the closest to each other. Okay, or probably I can find, let's say there is this data point and this data point. Okay, and then I can have this distance. Okay, this is the farthest data point. Or to have a average of this, so I will take the average of this. Okay, maybe here, and then I will have the average of this. Okay, so let us do it one by one. So the first distance that you can have between clusters is, it is called as single linkage. Okay, or it is called as minimum linkage. Okay. What do you mean by this? So you find out the data point that is closest to each other like this, and then find the distance of this. Okay, so I write it as, let's say, distance mean, okay, between two cluster, let's say Ci and Cj. Okay, such that, how do you find? You find the minimum of, let's say, x in Ci and y in Cj. Okay, you find the minimum distance of x and y. Okay, so this is the Euclidean distance. So find x and y such that they are closest to each other. Okay, and the distance should be minimum one. So what you have to do is you have to find out the distance from every point from A to every point with B and choose the minimum distance. That is what is the meaning of this. Okay, so find the minimum distance. So that is what is single linkage. Another model that obviously you will have is called as complete linkage. Okay, or max linkage. It is called as maximum linkage. What will be the mathematical model for this complete linkage or max linkage? It will be D max, okay, between two clusters C, let's say Ci and Cj, such that you will have the maximum distance. So x in Ci and y in Cj, and such that this will be maximum one. Okay, this we already specified. Okay, so for example, here let's say you have this two data point here, and let's say you have this four data points over here. So max linkage will be the distance between this to this, because this will be the maximum one. Okay, so this is what is D max. Okay, but to find out this D max, you have to have distances computed from this point, this cluster A to cluster B, all data points from cluster A to all data point of cluster B. Okay, so then and then only you will be able to find out the maximum distances. Okay, maximum distance. Okay, now third will be obviously the average. Okay, so it is what is called as average linkage, or it is called as Yeah, average linkage. So what will be the data model, the mathematical model for this? So let's say D average between Ci and Cj will be, so find out the distances between all x and y, okay, sum it up and average it. So it will be 1 by size of Ci into size of Cj, okay. And the third one, or sorry, the fourth one is the mean linkage, okay. It is called let's say d mean okay. So what you will do here, so if you have given, let's say, a cluster, okay, let's say cluster A, and there is another cluster called as cluster B, okay, and then you calculate the mean of this. So obviously you will add all those points first and then divide by number of points. So let's say this is what is your the centroid, and this is what is the centroid of this, okay. So probably it will be somewhere here, okay, and then you calculate this distance. So this is called as d mean, okay. So what is the difference between d mean and d average is that in d average you find out all distances and take the average of that. So that is what is the average distance. It is not, this is what is the distance between the means, and that is what is the average of the distances. So that is what is the basic difference between d mean and d average, okay. So you need to understand this. So how do you write this? So it will be the just the, say, mu I minus mu j square, okay. So it is the difference between the distance, sorry, the distance between the uh, two means or two centroids of that particular clusters, okay. So with this, what do, you find out the cluster distances. So this is for the finding out the cluster distance. If you have only 2 points, then there is nothing difficult to find out this, okay. So you have already find out the Euclidean distance. But if there are group of points, and then you say this is one cluster and this is another cluster, then which distance to be chosen? So you can have mean, you can have max, you can have average distance, and you can have mean of the distance between the mean of the clusters, okay. So when you will be asked with the problem, you will be given the data points and you will be asked to find the distances with the given given cluster distance model. So for example, you may be asked with the single linkage, or you may be asked with the max linkage, okay. So this is what is fundamentals about the cluster agglomerative clustering. Let me give you one example, okay. So I hope this is visible to you. Okay, so there are 6 clusters. So this is asking somewhere in I think the November, December 19. Okay, so there are 6 clusters: A, B, C, D, E, F, and given the 6 by 6 distance matrix. So this is what is the matrix given to you. It represents the distance between these clusters. So already, let's say there are 6 points only, and the distance is given. Okay, so solve it using hierarchical clustering algorithm, okay, and single linkage method. So here the method is specified that it is the single linkage method, and draw the associated dendrogram of it. Okay, so ultimately, if it is asked for 12 marks, so maybe probably 10 marks is for solving this, and 2 marks is for like drawing the dendrogram. Okay, now let us understand what is this. So A, B, C, D, E, F, the row head and column head represent the clusters or cluster names. A to A will be obviously 0, B to B will be 0, C to C, D to D, E to E, F to F will be 0. Okay. So it is kind of symmetric matrix. Okay, so let's look at this point 71. This represent that A to B is having the distance 0.71. So obviously B to A will be 71. Okay, so you read it in the row measure or column measure, it is one and the same. So A to C is 5.66, A to D 3.61, A to E 4.24, and A to F 3.20, like that. Okay, now what you have to do now. Okay, so as the for the first point, it is very easy. Okay, so here what is asked, that single linkage means mean linkage. So find out the two clusters which is having the minimum distance. So where you find the minimum one, so you have to just scan through this table, and probably you will find that here it is 0.50. Okay, it is 0.50, means D and F is having the minimum distance. Okay, so if you say I will draw it somewhere here. Okay, A, B, C, D, E, and F. Then which one will you merge first? It will be D and F. Okay, so let us merge it. What will happen? Okay, I will not draw the first matrix. I will maybe go with the second one. So let's say A, B, C, E, and I will write D and F directly. Okay, so A, B, C, E, and now D and F is merged. Why? Because it is the minimum one. Okay, it is the minimum one. So let me draw this line. Okay, now what about the remaining distance? Okay, A to A is dash, A to B is 0.71, so that you have to just copy. A to C is 5.66, so 5.66. A to E, A to E is 4.24. I hope you can see this. A to E is 4.24, so I will write 4.24. Okay, now what about A to DF? A to DF. Now, since D and F is merged, so you have to find out the distance between D and F. Okay, so D and F, considering D and F together, and since it is single linkage, so I will pick up the minimum value. Let's say 3.20. So I will say 3.20 here. Got it? So like that, A to B, no need to write because it is the symmetric one. So I will say B to B dash, B to C. Okay, B to C. B to C is sorry, this is B to C 4.95. So I'll say 4.95. B to E, B2 is 3.54. So I will write 3.54. Okay, and then B to DF, B to D is this, and B to F is this. So which one is minimum one? 2.50. So I will write 2.50. Okay, then ultimately C to C is dash, C to E. C to E is 1.41. So I will directly copy that value. Okay, and C to DF, C to D is this 2.24, and C to F is 2.50. So which one is minimum? 2.24. So I will copy that. E to E is dash, and E to F, E to DF, sorry, E to D is 1.0 and 1.12. So obviously I will write 1.0. Okay, that's it. And D to F is dash. If you want, you can copy down this value, or if you want, you can keep it as it is, because this is nothing but the symmetric one. So if you want, you can copy this 0.71, then 5.66, and like that. Okay, there is no need actually, but if you want to fill the matrix, you can fill like that. Okay, now this is what is the step number 2. Okay, this is step number 1. This is the dendrogram for step number 1. This is step number 2. Okay, now you have received this. Okay, now which one is the minimum one? So as you can see, A to B is the minimum one. So I will highlight that A to B as the minimum one. Okay, and here it was like this. Sorry, I can't highlight here. So A to B is 0.71. So obviously what you will do, you will merge A to B next. Okay, so after D and F, I will merge A to B. Okay, I will merge A to B. Okay, now since you merge A to B, what will be your next matrix? So it will be, let me write it. I will skip A, B. I will write C, E, D, F first, and then A, B last. Okay, so it will be C, E, D, F, and A, B. Okay, so let me draw these lines. Okay, then C to C dash, C to E, C to E you have 1.41. So I will directly copy that value. C to DF is already available, so it is 2.24. Okay, now C to AB. C to A is 5.66, C to B is 4.95. So which one is minimum? Is 4.95. I hope you can understand. So this, look at this value. Okay. Then C to E, E to E dash, E to DF is already there. It is 1.00. And E to AB, E to A is 4.24 and E to B is 3.54. So which one will you copy? You will copy which one? 3.54. Okay, so 3.54. DF to DF dash and DF to AB, DF to A is this. Okay, look at this. DF to A is 3.2 and DF to B is 2.5. So which one will you receive here? So it will be 2.50, and then ultimately AB to AB will be dash. Okay. Now what was the dendrogram looking like? Okay, AB and DF. Now look at this table. So this is what is your step number 3. Which one is the minimum one? So ultimately, this one is the minimum one. Okay. Now, which one to be merged? DF and E. Okay. So I will show you in the dendrogram. Okay. So DF and E. So ultimately, I will keep this E just outside so that you will understand DF and E, and then next will be merged like this, DF and E. Okay, and then what will be this distance matrix will look like? So C DF, sorry, not DF, I will say CF AB and DFE. Okay, C AB and DFE. So let me draw this matrix. Okay, C to C dash, AB to AB dash, and DFE DFE dash. Okay, C to AB, C to AB is already there, so 4.95. C to DFE, C to DF and E. So this DF and this E, which one is minimum? 1.41. So I will copy 1.41. AB to DFE, AB to DFE. So DFE, where is DFE? So this is DF and this is E. Just carefully observe this. And which one is minimum? 2.50. That's it. And then what is the next thing to be merged in step number 4? Look at this. Which one is minimum? AB and DFE. Okay. So what will you merge? AB and DFE. So if you look here, AB and DFE will be merged. Okay. So next, maybe C and A, B, D, F, E. C and A, B, D, F, E. Okay. And then there will be only one value remaining. That is the distance between C to ABDFE. C to ABDFE will be 1 point. Oh, sorry. Just a minute. I just made a mistake, I think. Okay. It is not ABDFE. It is what is 1.41. So this is not there. Which one is minimum? 1.41 is minimum. So C to DFE. So what you will merge? A, B will be there, and then C with DFE. So C, D, E, F or DFE, whatever you say. Okay. It will be A, B, and C, D, E, F. Okay. And then your dendrogram will be look like, you will have C, D, E, F. Okay. And then what is the distance? AB to CDF, AB to CDFE. So it is what? 4.95 and 2.50. So it will be 2.50. Okay. Or, and this is ultimately CDFE to AB, it's one and the same. So it is 2.50. And then ultimately you will have ABCDFE. So last cluster or last dendrogram will be look like this. So this will be like this. Okay. and ultimately you will have A, B, C, D, E, F versus A, B, C, D, E, F. Okay, this. If you okay, look at this. If you draw the diagram or the Venn diagram for this hierarchical clustering, okay. So let me just this. Okay, this is D, this is F. Okay. So this is included first, or this is merged first. Then what you have is A, B. Okay. So I will have A here and B here. Okay. So A and B. I hope you can see. This is just a level away. So this is merge next. Okay. Then DFE is merged. So here you will have the third cluster or third data point, which is E. Okay. And then this is included in this. Okay. And then next is C, D, F, E. So C is included. So I will draw a red point here. Okay. C. Then C is included in this cluster. Okay. And ultimately A, B, C, D, E, F, E is made as one cluster. So this is a final value or final cluster. Okay. So you can have this as a dendrogram, or you can have as a, okay. So I will write the dendrogram nicely. So let's say this is D and, sorry, this is F. Okay. So this is D and F. So first D and F is merge. Okay. Then what is merge? Let's say this is, sorry, A and B is merge. Okay. Then E is merge. So E is merged with DF. So this is E. Okay. And then C is merged. Okay. So C. And finally this is merged. Okay. So now if you want to, so the thing is with this particular dendrogram is that if you want to take, let's say if you want to find only two clusters. So what is the beauty of this dendrogram is that, say, let us say you can cut it at this particular line. So if you take the intersection at this, okay, what will happen? You will have two clusters, right? So ultimately you will have DEFC in one cluster and AB in another cluster. Okay. So if you want to have, let's say, three clusters, so you go on finding this. Okay. So you will have this DFE1, C1, okay, and then AB as one cluster. Then if you go on, like say having, then you will have DF as one cluster, E as one cluster, C as one cluster, and AB as one cluster. And then ultimately, if you go and have an intersection at this, then you will have all 6 data points as one, the different clusters. Okay. So at every level, if you take the intersection, you will have that number of clusters. Okay. That's why the initially this value is not given. Okay. Which one? The K, the number of clusters. Okay. And that's why you can have different clusters at different levels. Okay. So this is what is the different steps that you have to work out for finding out the this hierarchical clustering of given data using the agglomerative. Okay. So this is for 12 marks, 10 is for all this tabular calculation, and probably 2 marks is for your dendrogram. So you can have this dendrogram as well as this Venn diagram. Okay. So it is very easy. So don't draw only dendrogram. So you can have this dendro as well as this Venn diagram. Okay. That's it. Okay.
Thank you very much for watching this video. If you have liked this video, please click on like button and subscribe to my YouTube channel. And please write your suggestion, queries in the comment box. or mail me at dineshjende@gmail.com. Thank you very much.